Hi Calculus, welcome back. So today is our very last lesson. We've got two assignments on this topic, but we're just going to do one video lesson to kind of combine the two. So our objective today is going to be to solve related rates problems. I have the checklist on the screen. You know what to do from here. All right, so to start your notes, would you please write related rates strategy? And let's fill this in together. So the first thing we're going to do is to write an equation if one isn't given. And this equation is going to relate all variables. Okay, so write an equation that relates all variables if one isn't given. So sometimes they put the equation right in the problem for us and we can skip step one. So I do want to make a little caveat here. If our equation is a right, or if our problem involves a right triangle, then please draw it out. Okay. All right, now for step 2, we're going to plug in any constant values. Okay, so plug-ins. And now we're going to be back to what we were doing in the previous lesson. Okay, so we're going to make a chart for the remaining variables. All right, and then we are going to go to our equation and derive both sides with respect to time, t, and then we will solve for the derivative that we're interested in. Okay, so that is our strategy. So what I'm going to do now is actually go through 3 of the problems from your assignment. If you have them printed in front of you, that's great. Otherwise, I'll give you some time before each one to pause the screen and write the problem down so you have it in front of you. All right, I'm forced to pause on your screen. If you don't have your assignment printed out in front of you, please copy this example. If you do have it, take some time to read this question and then hit continue when you're ready to talk through it. We are back. So step 1 is we need an equation that relates the variable. So I need an equation that relates the area of a circle to its radius. So what would that be? That is going to be a equals pi r squared. Okay, so that's step 1. We are not using a triangle, so I don't need to draw anything out. Now, step 2 is to plug in any constant values. So I've got a and I've got r. Is a constant or a is changing? A is changing, right? What about r? R is also changing, right? So no constant. So now I move on to step 3, which is going to be to make a chart for the remaining variables. Okay, so that would be A and R. So now we're back to what we did with our basic related rates. Okay, so I'm going to put A and R as well as dA dt and dr dt. Okay, and now what I do is I can just zone in on the numbers it gave me. Here's what I mean. The first number I see is 5 inches. So where on the table would you put that? That is going to go with R, right? The next number I see is 2. Notice inches per minute. Where is that going to go? That is going to go with dr dt. Notice its units tell you that it's a derivative, right? It's got something over some unit of time. It also says that the radius is changing at a rate. So the rate, that's the derivative of the radius with respect to time, okay? And so what are we looking for? Well, it says how fast is the area's area changing at this time? Well, how fast means we're looking for a derivative, right? So we are looking for dA dt. So let's put our question mark there. All right, so we've filled out our chart. Now we're on step 4. So now we're going to derive with respect to t. So I'm going to take both sides of the equation and derive with respect to t. So the left side would just be dA dt. The right side is going to be 2 pi r dr dt, right? And now let's go ahead and plug in these values. I'm going to go ahead and pause, and you go ahead and plug in as well. All right, so I am getting 20 pi. These you should be able to do all of these without a calculator, so please leave them in exact form. Now let's talk about units, okay? So we were looking for the change in area over time. Look at what we were solving for, right? And so I need some unit of area over some unit of time. So area has how many dimensions? 2. And notice our dimension of length or space was inches. So I'm going to have inches squared for area over, and now I need a unit of time, which was minutes. So final answer, 20 pi inches squared per minute. And what are we doing here? Well, what we're doing is we've got this circle that's changing, and we're freeze framing at a certain moment in time. We're freeze framing right when the circle's radius is 5, okay? So it's really, really important here that you do not plug in these numbers until after you differentiate, because they're not constant, okay? So we cannot plug our values in here until after we've taken the derivative. Okay, we can only plug them in if they're stagnant. In other words, they don't move. All right, and first pause on your screen. We're going to do question 5 next. We are back. So this time we are looking at a rectangle, right? And we need to relate the area to the length and width, but notice we already were given the equation there, okay? So I'm just gonna rewrite that A equals L, and I'm just gonna go times W here, okay? So step 1 done for us, not a triangle, I don't need to draw it out. Step 2 is plug in any constants. So I've got 3 letters going on here, right? So area, is it changing or it's constant? It is changing. What about length? It is also changing. And what about width? Also changing, okay? So step 2, there are no constants to plug in, but you all do not skip step 2 because you will need it. If you do have a constant, it's going to be very difficult to solve these if you don't plug that in, all right? Okay, so we've got 3 variables. I'm going to go A, L, and W, and of course the order you put these in your chart does not matter. And then let's put the derivatives to the right here. Hopefully you got good at making these charts with your previous assignment. Okay. All right, so now we're going to plug in again. Now just zone in on those numbers. Okay, so the first number I see is 10 inches. Now is this going to go in the left-hand column or the right-hand column? This is going to go in the left-hand column. Where do you want to put this? We'll put it with L. The length is 10. The next number I see is 6. Where should we put this? The width is 6, so I'm going to put that with W. The next number I see is 2, but let's be really careful. It says the length is decreasing at a rate of 2 inches per second. So I know it's going to go with dl dt because the length, it's the rate of the length, the derivative of the length. However, we need a what? We need a negative to indicate that decreasing portion, okay? And then the width is increasing at a rate of 0.5 inches per second. So I'm going to have a positive 0.5 here. Let me pick a bit better color. All right. And that's all I see in terms of numbers. So now I need to figure out, what am I looking for? It says at what rate is the area changing? So am I looking for A or dA dt? dA dt. You'll pretty much always be looking for a derivative, okay? I don't have A, but of course I could find it if I needed by plugging in 10 and 6 for L and W respectively into the original equation. Okay, so now what's our next step? We can derive with respect to time. What I do to one side, I have to do to the other. All right, any special rules on the left-hand side? No special rules, dA dt. What about on the right-hand side? Right-hand side, I do need product rule, right? I tried to put that times to kind of indicate that. So derive the first with respect to time, that'll be dl dt. Hold the second, right? Plus, now hold the first, L, derive the second, which will be dw dt, and I always think of Arthur there. Okay, all right, I'm going to pause, go ahead and plug in the values, and then we'll have dA dt. All right, I'm getting -7, but again, we're not quite done. Always tack on units here, okay? And really try to tack on units before you look at the key. I did give you the answer right within the assignment for each question. So again, this is a change, the rate of change of area. So we need some unit of area over time. Again, area has how many dimensions? 2, so I would need inches squared over, and what unit of time? Seconds. So final answer, -7 inches squared per second. To get a negative answer, what do we think that means? It means the area is decreasing at this particular moment in time. All right, the last one we're going to do together is number 10 from your assignment, and I'm going to go ahead and force a pause. Okay, so it tells us that we are going to use Pythagorean theorem. This is also going to be a triangle, right? So we are going to need, of course, to write our own equation, which they say is going to be Pythagorean theorem. We're also going to need to draw this out, okay? So I've got a camera and a rocket ship not drawn to scale here. And what's going on is that camera is going to pivot, but essentially stay in that spot. But the rocket ship is going to move up, right? Okay, so what we're going to do is let's draw a triangle here. So let's connect the camera to the rocket ship and then come down. And we'll go across here, okay? So this is going to be our right triangle. All right, now out of these distances, okay, so for now, let's say that I like to make my horizontal distance an x, vertical a y, and I'll make this z. Out of any of those distances, are any of them constant? X is constant, right? So here's what you need to do when you do your triangles. Put that number there, okay? Don't leave it as an x, because if you leave it as an x, we're assuming that it's varying, and that distance is not varying. And what's going to happen is if you leave that as a variable, you're going to end up getting this derivative in there that you don't quite know what to do with sometimes. So we know that this distance, well, the camera is mounted 3,000 feet horizontally from the Space Shuttle launching pad, right? So I'm going to go ahead and plug 3,000 in there right away, okay? So I'm kind of doing step 2 within step 1, making sure that I am very cognizant about my constants, okay? It's going to save you a lot of work in the long run. All right, so we need an equation. Well, we can relate our variables here using Pythagorean theorem, right? So I'm going to have 3,000 squared plus y squared equals z squared, right? Okay, now we've taken care of our constants. I've already plugged that 3,000 in. Z and y are the pieces that are moving, that are changing. So that's what I need to make my table for. So let's go ahead and do that down here. So I'm going to have y and z as well as their derivatives with respect to time. Okay, now let's zone in on the other numbers. So the next number I see is 800, okay? So it says the shuttle is rising vertically at a rate of 800 feet per second. So kind of 2 clues there that this is a derivative, right? So is this dy dt or dz dt? This is dy dt, so I'm going to put 800 there. When it is 4,000 feet high, so where would you like to put this? Yeah, let's put this with y, okay? How fast is the camera to shuttle distance changing? Well, that how fast tells me I'm looking for a rate. There's only one rate left, that's dz dt, and notice that z is the distance from camera to shuttle, right? So I want to know how fast that's changing. I want to know dz's derivative. Okay, so now let's go ahead and derive both sides with respect to time. All right, now be careful. Any special rules on the left? No special rules, I can go term by term, but what's the derivative of 3,000 squared? It's 0, okay? And this is what is really going to help us out in the long run. That's a constant. Its derivative is 0, goes away. So let's go to y squared. Its derivative will be 2y dy dt, and then the derivative of z squared will be 2z dz dt. Okay, here's what I recommend. This will happen very often with Pythagorean theorem. Let's divide everything by 2 and just get rid of those guys just to make our lives easier. It's always a good idea to do a little bit of algebra in the beginning to make our lives easier in the end. Okay, so let's see, I'm going to plug in. I've got y, I've got dy dt, but I do not have z, right? So I can come back here to figure out what z is in the moment that I freeze frame. Okay, the moment I'm freeze framing is when my vertical distance, when y is 4,000. Okay, so if I plug in 4,000 to y, can you tell I'm going to get a 3, 4, 5 triangle? Yeah, so z is going to be 5,000. Okay, so now we have everything we need to plug in. I'm gonna go ahead and pause. You plug in, and then let's solve for dz dt. All right, unsimplified, this is what I'm getting, 4,000 times 800 all over 5,000. Let's go ahead and clean this up a little bit. I can knock off 3 zeros in both numerator and denominator, so that leaves me with 3,200 over 5, which is going to be 640. There we go. All right, and talking about units, how many dimensions is z? Just one. So the units of z would be in feet, and the units of time would be in seconds. So that is the last one we're going to do. Congratulations on finishing your last video lesson of the semester. And again, you'll have 2 assignments based off this, this lesson, but I'm not going to do an additional video for it, so you should be good to go. Let me know what questions you have, and I will see you in class.